All right, everybody, section 5.8, calculations with net ionic equations. Now, net ionic equations, if you remember, those are the equations that show which ions are actually involved in producing a product. For instance, the net ionic equation, oh, that's what that does. Okay. We've got a net ionic equation shown below compared to the overall molecular equation. Our molecular equation, is going to be silver nitrate, aqueous, reacts with sodium chloride, aqueous, to produce a precipitate or a solid. I'm going to write pt8, silver chloride, and there's still sodium nitrate, aqueous, left in the solution. Okay, now if you remember our net ionic equation, we go from a molecular to ionic to an ionic to a net ionic equation, and that's what we're left with right here. Net ionic, where we omit any of the spectator ions, basically the things that are not involved in producing our product, and our product is the solid AgCl. Now, it's been a little bit of time since we talked about this, so think back to what are some other potential products that you could be generating. And what I mean by that, or what I want you to think about, is not necessarily other solids, but we could also be producing liquid H2O. That's commonly a acid-base reaction that you'll see, and that would be the product that you're leading up to. But for this particular question, we're going to go ahead and work some things out with it, and some things that you might see. So this question right here presents us with our molecular formula, or our molecular equation, as well as our net ionic equation. Our net ionic equation is this lower of the two, net ionic. And what we want to know is what amount of silver ions is needed to make 100 grams of AgCl. Okay, now this is a little bit of a complicated question. In the event that you encounter a question that is specifically asking for the mass of silver ions, we'll answer that. And the way that you answer that is by looking at the net ionic equation and looking at your molar ratios and needing the molar masses from that net ionic equation. Now, in the event that the question is asking, well, how much of a silver ion containing compound is needed? Well, that's a little bit more realistic of a question because of the fact that, well, you simply can't weigh out silver ions on their own. They're going to be a part of an ionic compound like silver nitrate. So what we're going to do is we're going to figure out for this question what Ag plus amount, and I'm going to put in grams, is needed. And to answer that question, what we're going to do is we're going to start out with what we know. We want to know how much is needed to make 100 grams of AgCl. AgCl. Okay, so now what I need to do is I need to convert to moles of AgCl. The molar mass of silver chloride, I've got it written down on my paper here, is 143.32 grams of AgCl. That's 1 mole of AgCl. Okay. Now I'm going to look at my net ionic equation because what I want to know is I want to know the amount of silver ions, the mass of silver ions specifically. So I'm going to say 1 mole of AgCl is going to come from 1 mole of Ag plus ions. Now the next thing is going to be, what's my mass of a silver ion? 1 mole Ag plus is going to be 107.86 grams of Ag plus. Now you might be looking at that and thinking, oh, but this is an ion. Should the mass be different from that which is on the periodic table? And to answer that question is, well, you're right, they are different, but it's a negligible difference because think about the difference between an ion and a uncharged atom. Well, that's a single electron. And an electron, well, the mass is negligible, or the mass of an electron is negligible. Okay, so this is what I've got set up, and this is what I want to do. I'm going to go ahead and punch in 100 times 1 times 1 times 107.86. Divide that by 143.32. And I get this right here, 75.26 grams of silver ions. Okay, so I hope that was helpful. The key to this is understanding the question that's being asked. Okay, now if the alternative was presented and you were asked about the amount of AgNO3, well, I'm just going to highlight what you would change right here. So we have the exact same setup, but we wouldn't be using the net ionic equation, we'd be using the molecular equation. And we'd be wanting to relate the moles of silver chloride to the moles of silver nitrate. And so where I've highlighted in your dimensional analysis, that's going to go from Ag plus to AgNO3. This is going to go to AgNO3, and your molar mass is going to be the molar mass for AgNO3. Well, I hope that sums it up. If you have any questions, please feel free, but I know you got this. You're good. But if you have questions, I'll help you out. Thank you very much.